Hi friends, welcome to Fresh Library YouTube channel. Today in this session we are going to discuss about complex data types. Complex data type. Okay, so before proceeding into today's session, let's have an idea about our previous class. Okay, in the previous class, what we have discussed is uh, integer data types, and we are having four types of integer data types. They are decimal, binary, octal, hexadecimal. In these four, decimal number system is the default data type in the Python. Default data type in the Python. And next one, binary. Binary means zeros and ones. It consists of zeros and ones. Next, octal. Uh, the range of octal form is 0 to 7. We can represent these kind of octal forms by using small o's or capital o's. Okay, small o's or capital o's. And hexadecimal. Hexadecimal base number is 16. In this we can represent the numbers from 0 to 9 and the alphabets from small a to capital small a to small f and capital A to capital F. And then we have discussed about base conversions from hexadecimal to binary, binary to octal, octal to hexadecimal. How we can convert is by using this bin of bin means binary, and the number we have to specify here which are going to convert, which we want to convert. Then it will automatically convert like this. Okay, and then float data type. Float means point values 1.0, 2.1, 3.5, like that. Those kind of numbers will be called as an float data type. Float data type. Okay. These are the examples of float data type. If you want to know which data type we had given to the Python or PyCharm, then we must type by using this command, type of F or type of E. These are the variable names. If you specify like that, then it will give the which data type we have given. Okay, and then here exponential also. Exponential are used to store the values in less memory, storing the values in less memory. Next to bool data type. Bools means either true or false. If the condition is true, then it will print out that true. If the condition is not true, then it will print false. So till here we have discussed in the last class. Now in this session we are going to discuss about complex data types. Complex data type. First of all, what is complex data type? Complex data types means which consist of both real and imaginary parts. Real and imaginary parts. How we can represent the complex numbers? How they look like? Let's have an idea about this one. Complex numbers consist of both real and imaginary parts, like this. Just I'm opening the ideally. So suppose A equal to 4 plus 5j. So in this 4 is the real part and bj is the imaginary part. Okay, bj is the 5j is the imaginary part. Okay, let's presenter to know about whether it is accepting that type of data types or not. If it doesn't show error, then it means that it is accepting that values. If it shows error, that means that it will not accepting those kind of data types or values. So here it is not shown any errors, so this means that it is accepting. Okay, so a is the variable, 4 is the real part, 5g is the imaginary part. Next, here I am going to specify the definition for this, which I mean some uh, idea about it by writing the definition for it. Okay, so a complex data type, a complex data type is the form of which form, what we have specified, a equal to 4 plus 5j. We had given like that only, right? So in this, 4 is the real part and 5j, 5 is the imaginary part. And j is the square root. Square root of -1. Okay. Let me give another inputs to the ideally to know whether it is accepting all kind of data types or not. Okay. Let's go to ideally. I'm going to give a equal to 3 plus 4i. Here in previous we have given j. Okay, 4 plus 5j. Now I'm giving another type of input, means another type of alphabet. Instead of j, I'm going to give another type. Okay, let's take here b. B equal to 3 plus 4i. Is it accept or not? No, it will not accept. It will throw error. It will throw error because it will accept only j kind of alphabet only. Only j alphabet only. It will accept in complex data type. It will accept only j. If you give any other alphabets, it won't accept. It will not accept. Okay, it will throw an error. Let's try with another. But before trying with another input, let's try to know which type of data type we have given. Which type of data we have given in past. Okay, type of a equal to So here, this is the complex data type. This is the complex data type. Okay. Now we can try with the another input. Let's see equal to 1.5 plus. We can give any kind of number. 2.5, not 2.5 j. Is it accept or not? It will accept or not, because we have given real part and imaginary part, and we have specified j only instead of any other alphabets. Like here we have specified only j. So is it accept or not? I mean here 1.5 is the float data type and 2.5 also float data type, but if we add j for that, then it will comes under in complex data type. So here we are combining both that float data type and complex data type. Let's try whether it will accept or not. It will accept. It doesn't show any error. That means that it is accepting the this kind of data types. Okay. Next. Wait. Give me a minute. Give me a minute. So here I'm going to write the notes for that. Instead of A5, let's take here B. Instead of 4, let's take A. We can take any value. For understanding purpose only, I'm going to write like this. Okay. We are already tried with different kinds of inputs also. It is accepted. It was accepted. So there is no issue. Okay. And so here A and B. For understanding purpose only, I have changed the inputs. A and B contains A and B contains integers or floating point values. Floating point values. Floating point values. Okay. Next. And in the real part, if we use int values, if we use int values means integer values. Integer also one data type in Python. Int values, then we can specify that either by decimal. Either by decimal. But not only with decimal, we can also specify decimal, octal, binary, or hexadecimal. Hexadecimal. What is the base value of hexadecimal? Base value is 16. For binary, 2. For octal, 8. Okay. Hexadecimal form. Sorry, in my keyboard F is not working properly. That's why always F is missing while typing. Okay. Form. But imaginary part should be specified only by using decimal form. Let me explain you this point clearly. So what it is saying that, so here this is the real part, right? And this is the imaginary part. So what we have discussed in this point is we can give here any binary data type, octal data type, decimal or hexadecimal before plus. But after plus, there is an imaginary part called 2.5, right? So in this, we need to specify the values in between decimal forms only. In between, we can give the data types from only decimal format. Okay, it will not accept any other formats, and decimal is the default data type in the Python. So here I'm going to give different kinds of inputs like binary or octal numbers in the imaginary part. Let's try. A equal to 3 plus 0b. So binary numbers are represented in 0b, octal 0o. For hexadecimal 0x. For decimal we will not specify any number. Okay, so 0b 0b 1010j 1010j. Is it accept? It will not accept because in imaginary part, in real part, we have given decimal type of number system only, but in imaginary part, we have not specified, we have not only given decimal number, we have given binary data type. So it will not accept. It will throw in a syntax error. It will throw a syntax error. But let's try in another way. Let's a equal to same 0b 0b 1010 plus 3j. We have reversed the numbers. Okay, imaginary to real part, real to imaginary part. Let's try. Is it accept or not? It will accept, because why it is accepting, that's why he's in the last point we have discussed about, in for real part we can give any kind of numbers, I mean any data type, but for a imaginary part we have to give only decimals and j only. Instead of decimal number, instead of j, if you give any other alphabet, it won't accept. That's what he is saying here, like that. Okay, that is the meaning of this one. Let's write some examples for that. Examples. Why we need another? Let's copy paste this, otherwise we will specify. A equal to 3 plus 4j, 3 plus 4j. This is the example of complexity type. And a equal to 1.5 plus 2.5 j. What is the difference between here and here? Here we have specified decimal form, decimal data type, and with complex data type. Here we had specified, we had written float data type. 1.5 and 2.5 are comes under in float data type price. That is the second example of this one. And third one, a equal to 3 plus 0b 0b 1010 j. Is it accept? No, it will not accept, because imaginary part won't accept binary octal hexadecimal. It only accept decimal and j only. So it is an invalid. Next, a equal to, but if we change the imaginary part to real part, real part to imaginary part, then it will accept 1010 plus 3j. Is it valid condition or not? It's a valid condition. So we can give any data type part in real part, but not in imaginary part. Let's have one point. Complex data type has inbuilt attributes to retrieve the real part and imaginary part. Real part and imaginary part. So a complex data type has inbuilt attributes to retrieve what is real part and what is imaginary part. So here we need to specify. Of course, here in the above only we have specified. A is here, A is a real part and 4 is the imaginary part and J is the square root. Okay, yeah, that's all for this session. If you have any doubts regarding this session, please comment below. Uh, I hope this video is helpful for you. Thanks for watching.